Right. So I'm going to be talking about today is my part of this Disaster 2.0 project that I've been working on for the last 9 months, roughly. And it's actually trying to bring some practical use for these ontologies in the context of disasters and emergencies. And actually, let me just outline my talk. So first, we're going to look at something quite basic, which is just getting a common language out there. What do we mean when we say disasters? What are we talking about when we say resource management? And what are the problems that you might come across? Then I'll talk a little bit about linked open data and move on to describing the piece of software that we've come up with and look at how we've addressed some of the challenges that we set out before, what's not addressed, and so on, and then have a look at the future work. So the first thing I want to talk about is, just so we're on the same page, what are the disasters that we're hoping to deal with? And so the characteristics of disasters, we see them, is that the scale is very large, so they're large-scale things, and there's a hazard against a vulnerability that kind of they don't match up. The hazard is greater, and the vulnerability is high as well. And there's certain kinds of disasters which are kind of expected, so the things that you can kind of expect, whereas there's some things which you can't plan for in advance and might just need to be dealt with on the spur of the moment. And you have the fact that the main thing is that there's a affected population which don't have the resources to respond themselves, okay? And this is a nice reference from 2008 where they kind of try and define what is meant by a disaster. And we also have particular cases where we see disasters on television and that are reported in the media. And this is how we kind of relate to the work that we're doing. And one of these is the Haiti earthquake, which it killed a huge number of people and it displaced an even greater number. And it was unpredicted. So, I mean, the seaport was demolished and the airport was out of fuel for days. So planes that were landing had to bring in enough fuel to be able to take off themselves. And 2 days after the crisis struck, there was 4,000 metric tons of aid supplies sitting in the airport. And there were charities like Save the Children saying things like, the planes haven't been unloaded. There's a huge amount of difficulty in getting the aid out to the people who need it. And 4 days later, this is quite shocking when you compare back to the 4,000 tons, is the American Red Cross runs out of medical supplies in Haiti. So they say, well, okay, we've got 4,000 tons sitting in the airport, but we've run out at the same time of medical supplies. So we need more things to come in. And later there were things about how some of the aid was not getting into the hands of the people who needed it. And something more recent, this is almost 3 years after the disaster, was that despite billions of dollars spent on this aid and these resources being sent into Haiti, rebuilding has barely begun, and a third of the people who are affected by this crisis are still affected by it. So, going back to disaster and some of the challenges that it poses to us, coming back to this point of exceeding the ability of the local population to be able to respond using its own resources. You need to get resources into this situation. But it's not just that. It's that the resources have to be managed by the responder groups. And they need to form a coherent response. They can't just everybody tries to brute force it and you have this silo effect where everybody's working independently. And you have all these multiple responder groups as well. You have government, non-governmental organizations, private individuals even coming in to try and resolve the problems. We've got all these different places where these groups can come in from. And also you get this independence, which I think is quite nice, is that you have all of these independent groups from different backgrounds and different abilities coming in to work together. So these are the kinds of things that we want to be able to work with. And the way that we look at this is our way towards solving this is to make sure that the response can be online. Okay? So by that I mean not paper-based. And you want cooperation between all of the organizations. So you have these interdependent organizations, the fire service depending on the ambulance and so on, and the Red Cross depending on the airport, let's say, that have to work together. And they do so in a decentralized way. Naturally, these organizations have separate bases. They work on their own, but they need to work together. And another important issue is to deal with the interoperability. So all of these organizations have their own systems. They must have something in place to deal with the resources they have. So whether it's paper-based, whether it's offline, online, they have some existing system to manage the resources they have. Right. And some of the premises that we're trying to deal with, or some of the premises that we're looking at for emergency response systems here. And some of these are just defined as the things that you need in an emergency response system. And the ones that we focused on are in bold. So we don't try to resolve all of these issues, but we try to focus on just 3 of these, which is we want to develop a system that's going to be in regular use before the disaster, so it can be useful during the disaster. We want open information exchange, and we're going to use linked open data for that. And we want to be able to build crisis memory. Now this is a very important point, is crises happen, and okay, they're not predictable, but you have crises that happen before that you can learn from. So if there's a crisis happened in the past, you want to be able to pull up the information from that and see how you can apply that to the current situation. And right. So for the practitioners in the room, I'll just go over quickly a view of semantic web and linked open data. And these are ways of publishing data online in a way that multiple organizations can access your data, view it freely, and using standard forms, okay, standard formats. And you use standard web-based formats, so like RDF and Sparkle over existing web standards. And you have these, in fact on the right, we've seen this figure before, which is all the data sets that are available online for people to freely access about whatever you choose to make available. And you link this data together using, well, as triples, using subject, predicate, object, which is you have a thing that you're trying to describe, which is the subject. You have a predicate which links it to another object. Okay? And you use URIs to uniquely identify the things that you're trying to describe. And you also have ontologies that you take your predicates from. Okay, so that's just a quick overview of linked open data and semantic web. Now, what we've come up with is actually a way for using these principles, and I'll explain how we use these principles, to have multiple organizations, each be independent and at the same time cooperative. So each independent site, what they can do is organize their own resources how they would like to, and they can have their own resource databases. So in this example we have a local council, and they have their resource database. And even though they're independent from the other organizations on this diagram, what they can do is they can search, for example, the fire service here can search the local hospital for its resources. And when I'm talking about resources here, I'm talking in the general sense of physical things. So for a hospital, for a local hospital, this might be the availability of beds in that hospital. So the fire service can check in the local area what resources are available at the local hospital at the current time. And as well as this, what they can do is make requests for these resources. So instead of having to manually pick up the phone, they could use an app or a website to make a request for a particular item. And the fire service can then send a response back for this request. And this happens completely distributedly. So all of these sites are independent. The local council doesn't need to give control of its site to the fire service, and it's not centralized. There's not one server. Everybody runs their own server. Everybody's in control of their own data. Right. And to do this, to create this system, what I've come up with is a protocol that's it's a lightweight protocol that uses linked open data for allowing for searches for resources and to make responses and requests within this network. And so what a site can do, we've just got a workflow here. A site, let's say the BHAM site here, could send a search request to an Aston site and get the results back. The responder here, who's the dotted man, will be able to make a request for a resource, fill in the details of what they're looking for, and the responder on the Aston site can either accept or reject this request. And now these sites, they remain independent, but they're using the same open data protocol between them. Okay. And another important thing is the sites, the independent sites, they have the choice as to where, which site they subscribe to. So you don't have to have everyone subscribing to each other. It's just by choice that they subscribe to the local sites nearby them. So we've developed this prototypical implementation which allows you to manage your own resources on your own site, as you would. But also, it lets you have a look at the external resources that are available. So you can list and you can search through the other sites in the network for what's available. And you can also make requests for the resources that are on external sites. And you can also either make your own responses or for requests made to you, or view what responses people have made to your requests. Okay? Right. So some of the issues that we've tried to address with this is to make an online system which is decentralized, so you don't have a single server sitting somewhere as a bottleneck or point of failure. It's cooperative, so independent organizations can work together without giving up any control of what they're in charge of. And it's interoperable, so you could use this with your existing systems and a small layer of compatibility that will let you reuse existing resource management systems with this architecture. And also, some of the things that we've tried to address are this kind of system should be in regular use. You track your resources, and then when it comes to a need for a request, or you can make it via the system. Of course, we use linked open data, so it's an open information exchange, and you can learn from previous crises because you can see, okay, there was a fire here last year. what requests were made and what responses were given from a previous crisis. Right. So some of the future work that we're going to do on this is publish it under the GPL, so anybody can download this software and use it for themselves. We're going to try and make it a bit more easier to use, so anyone can come and download it and install it on their server to manage their own resources, and allow them to do backups and mirroring. Also, we want to do some kind of access control. It might not be great that the whole world could read what resources you have available. So we'd like to have some security built in that would stop anyone from reading you. Just allow the people who you've given access to read your information about resources and requests and responses. And also trying to build in some kind of backup mechanism. If the internet isn't available, having some alternate interfaces like SMS and mobile phone, and also joining the network. This is a problem we haven't solved yet, is in a decentralized system, how you join a network is a difficult problem. So the way Facebook works in a social network example is they have a centralized list of who's connected to who. We don't want a centralized system because then we're relying on whatever centralized server is there to be there during a disaster, which wouldn't always work. And okay, before I move on to the questions, I think I've just got a couple of minutes just to show you this system in action running on this machine. So I've got some virtual machines that are running up. So what we've got here is the Aston site, and we've got the Birmingham site here. And what's happened in the Birmingham site is people have registered some resources, and they're mapped, they're displayed on the map. And in this case, there's only one, and it's somewhere in the Midlands of England. And you can, in fact, I'll just register a resource quickly. And one of the resources, in fact, this is a cut down version of the site. It will allow you to create an organization. So the resource that you're sharing to other people is an organization. It kind of, at the moment, it might not make sense to you, but you might have a vehicle here, somebody registering a vehicle, somebody registering a person, and you could fill in this information. And even though this is an independent site from the Aston site here, you can actually view what resources are on the Birmingham site from the Aston site. So you can see all of these aid organizations that are created on the Birmingham site, and you can even search for a particular kind of resource that you need. And the main aspect of this work was to allow people to create requests and responses for these resources. And that's where you come to the requests menu, which lets you go into the network and see what requests have been made for your resources, and even to create a request for a particular item from, for example, the Birmingham site. We've also developed this ontology for a protocol. So this is the protocol for sharing resources and requesting them. And another thing, which is one of our points on the future work, is we've published this code to GitHub. So anybody can download. If you don't know what GitHub is a place where you can share the source code of your project. So anyone can come along. And this is one of the outcomes of the hackathon that we were working on over the last weekend. And we also have a website which describes the tool in a little bit, well, lets you download it at least. Okay, so that's it from me. Do you have